Today I want to talk about something that's really at the heart of how Bitcoin actually works, and that is SHA-256 hashing. Now, if you've been in Bitcoin for even a little while, you've probably heard the term hash or SHA-256 thrown around. But what is it really? And how does it work? Why does Bitcoin use it so much? Let's unpack it. So first, what is a hash function? Think of it like this. A hash function is basically a special kind of math formula that takes any piece of data, could be a sentence, a picture, a whole book, it doesn't matter, and turns it into a fixed length string of characters. In the case of SHA-256, the hash is exactly 256 bits in binary, which is exactly 64 characters in hexadecimal. In Bitcoin, both the binary output and the hexadecimal output are used in different places. So any sized input equals a fixed sized output, and the output is deterministic. That means that every unique input has a unique output, and the same input always generates the same output. And here's another really cool part. It's one way. That means if I give you the output, the hash, you can't work backwards to figure out what the original input was. It's one way because information is destroyed in the process of generating the hash. It's like ripping a few pages out of a novel and burning the rest of the book. The few pages are enough to uniquely identify the book, but not enough to reconstruct the lost chapters. Let me give you an example. If I take the sentence, Bitcoin is money, and run it through SHA-256, I get a specific 64-character hash. If I change just one letter, say Bitcoin is money with a Z instead of an S, the hash becomes completely different. That's called the avalanche effect. Even a tiny change in the input will cause a massive difference in the output. It's pretty cool. So how does Bitcoin use SHA-256? Several important ways. First, mining. When miners are trying to find a block, they're basically taking a bunch of transactions and running them through SHA-256 over and over again. Why? They're trying to find a hash below a certain numerical value, called the difficulty. If the hash is higher than the difficulty, a random number is added called the nonce for number used once, and the transactions are rehashed. This is done repeatedly, often billions of trillions of times, before a block is found with a hash below the threshold value. But when it happens, that block is added to the tip of the blockchain. Because it takes many trillions of hashes to find a winning hash below the difficulty threshold, finding a block is called a proof of work because it proves you did the work. Also, the fact that it costs electricity to perform those hashes is what links the virtual currency to the real world, and is why we say Bitcoin is backed by energy. In hexadecimal, a smaller number will have more leading zeros than a larger number. In simple terms, you can think of the difficulty as the number of leading zeros required to win. As the difficulty has increased over the years, the number of leading zeros needed to win has also increased. Here are the winning hashes for block 5 when the difficulty was 1, and block 696,500 when the difficulty was 29 trillion. That is 29 trillion times harder than block 5. The hash for block 5 has 8 leading zeros, and the hash for 696,500 has 19 leading zeros. Second, SHA-256 hashing is used in Bitcoin addresses. When you create a Bitcoin address, SHA-256 is used along with another type of hashing that has a smaller output to turn your public key into that shorter address that you see starting with BC1. Third, Merkle trees. All the transactions in a block get hashed in pairs, and then those hashes get hashed together in pairs, and so on until you get to one single hash at the top, called the Merkle root. That gets put into the block header, and it's actually the block header that gets hashed when mining. The Merkle tree lets nodes efficiently verify that a transaction is really in a block without having to download every single transaction. And fourth, fingerprints. I'm sure you know that a wallet is a device that stores your public and private keys. You can give your wallet a name, any name you want, and you can change that name anytime you want. But every wallet also has a permanent identifier that is unique to that wallet, called a fingerprint. The fingerprint is the first 8 hexadecimal characters of the hash of the public key. Now, why is all of this so important? Because SHA-256 gives Bitcoin some super powerful properties. It makes the blockchain immutable, meaning once something is written into the chain, it's impossible to change it. If you tried to change even one transaction from the past, the transaction hash would change, which would change the Merkle root, which would change the block hash, which would change the hash of every block in the chain after that transaction. You'd have to redo all the proof of work for every block after the transaction you changed, and that's impossible. And that's why a transaction is considered permanently settled once it gets buried 6 blocks deep into the chain, about 1 hour. So to wrap up, SHA-256 is one of those quiet heroes in Bitcoin. You don't always see it, but it's working behind the scenes, keeping everything secure and verifiable. It's not flashy, but it's incredibly important. And understanding it just a little bit better helps you appreciate why Bitcoin is designed the way it is. If you enjoyed this, make sure to hit the like button and leave a comment letting me know what you'd like me to talk about next, and subscribe for more Bitcoin explainers. Thanks for watching, and I'll see you in the next one.